All right, video 3 and the last of our three-part series in Fire Department Connections, how to pump the FDC. All right, next we're going to talk about some pump considerations. Number one, once we've got everything connected, we know that we're hooked up to the right standpipe or sprinkler system. We've got to charge the lines and then throttle to a pressure. We'll typically set our pump discharge pressure at 150 psi. And then if we have a standpipe that we are supplying firefighters, we'll have a standpipe operator on the floor at which they made the connection, and he will adjust the attack line pressure with a gate valve and a gauge, which is part of the high-rise pack. When we're pumping sprinkler systems, we're going to go for 150. We can always adjust more for elevation as need be for extended lines. If we have to, for some reason, pump a distance, we can consider that friction loss. But more often than not, we're going to stick with 150 psi. That's our good starting point, and we can adjust from there. So what mode? Our engines have a pressure governor. You could have a relief valve, and our pressure governors are labeled as PSI mode. We have PSI mode or RPM mode. RPM mode, we literally manually adjust the throttle. Within PSI mode, the pressure governor adjusts the RPMs of the engine to maintain the pressure at which we set our pump. So the pump discharge pressure should stay the same. However, our RPMs may adjust. Say more sprinkler heads pop up, or they attach a second attack line and are flowing more. As there's more flow to maintain the pressure, engine RPMs are going to increase. The pressure will be the same, but we as operators must monitor the RPMs, the sound of our engine, and also, and most importantly, is the intake side. So you got two main gauges. You got the master discharge and the intake gauge. That intake gauge will give you, um, how much water is left available as you're flowing, and that may change as lines are opening and shutting. So at the lowest intake pressure, I mean, you've got the maximum number of lines open at that point. It's good to mark that or take a note of that, which will allow you to know whether you can pump more or not, or if a sprinkler system may be outrunning your engine, um, or I'm sorry, the fire is outrunning the sprinkler system. In other words, additional heads are popping, increasing that flow rate, or you have a ruptured hose line, or somebody left a nozzle open, and or whatever it is. You have increased flow on the discharge sides, decreasing your intake pressure, but your discharge pressure is remaining the same. So a tool for doing that, if you have one, is a wax pencil, marking that on your intake gauge, and then taking note of that reduction as more lines are added or things change throughout the time that you're pumping. All right, here's a big question. Should you supply attack lines as well? I think for the most part, when an engine is supplying a sprinkler or standpipe system, they typically do not. If it is a large enough structure, there's more hydrants that can be tapped into, and separate attack lines can be utilized. So one for attack lines, hand lines, and the other one's going to be for the sprinkler system. That's typically the norm, I believe. However, I think it also goes back to how much are you pumping. If you're pumping a very small amount, say it's an apartment complex that has that single 2.5 on there, we can estimate that flow based on just like the discharges for a fire pump, there's about 250 GPMs. That's like one, for us, larger hand line, say at 1/8 inch tip, 50 psi, flowing 265 ish. That's all that is. So sure, we can effectively pump more than that. We have 1,500 GPM pumpers in our fire department, and they typically range, somewhere just a little more, a little less than that, or around 1,500 on virtually any pumper. So sure, it should be pretty easy to pump an additional hand line or two on top of that. That's what we would do on a normal fire anyway. But it goes back to department preference, but I feel like smaller FDCs, absolutely, we can stretch some lines off of it. No need to pull a whole nother apparatus into pumping smaller flows. Larger flows, we would probably want to separate those functions. We also need to consider that the intake pressures may be reduced if we tap another hydrant as well, though, with an additional engine, especially if we go into, larger flows, larger lines on tech lines. All right. Another question is there another hydrant available? So, well, you can't do it if there's not one nearby, or if that other hydrant is a long ways off, and then we're having to relay pump in addition to supporting a standpipe or sprinkler system. So, a lot of things to consider. Um, we may not all have the same SOPs or SOGs for that, but there are things that departments need to think about and pre-plan for their department and or specific situations that you may run into. Okay, so what we've talked about from the beginning was the identification of FDCs and how they function and what they're tied into. We talked about how to make the connections, where to stage your apparatuses, and some pros and cons and tips for that. And finally, we discussed some basics about how to pump the fire department connection. That concludes our three-part series on FDCs. I hope it was informative.